Hello again. This is Scott Johnson, Dad on Rails, and my last essay was around databases, and in particular, relational databases. And I just realized that I talked in a very abstract fashion about relational databases, and I never once told you what database to use. And wow, that's a fail. That's all right. I am human, profoundly human. I fail a lot. All right, so let us talk about the relational databases in the world, of which there are many, and let's talk about what you might use and why you might use them. Okay, so I am at heart what's called an open source programmer. Okay, and this means I use a bunch of tools that are community written. I follow an ethos which generally amounts to ship early, ship often, and I believe that with enough eyes, all bugs are shallow. These are themes that I will come back to later, but I believe in them firmly, and that's why I'm going to start with the open source databases. Now, there are a bunch of open source databases, but when push comes to shove, there are exactly 3 that really matter. These open source databases are called SQLite, MySQL, and Postgres. Okay? There are a whole bunch more open source databases. These are the ones that I use. They're the ones that are most commonly used, and they're the ones that you will run into in the wild. All right. So the first thing to understand is that you use a database to store data, and the database that you use will offer different features, and that will affect how you build your application. Okay? Can you move data across databases? Absolutely. I called this video podcast, or whatever the heck this is, video series, Dad on Rails, because mostly we're going to be talking about the Ruby on Rails programming environment. And in the Ruby on Rails world, there's a facility called Active Record, and Active Record gives an interface across databases, and simply by changing what's called the adapter, the piece of software that talks between your application and the data store, you can move your stuff higgledy-piggledy across different databases. Now, that said, it's a great feature. You are never going to do this. I have never once woken up and said, aha, I must move my data from MySQL to Postgres. Quite honestly, it just doesn't happen. You pick a database because you like it, because you understand it, because you know its features, and most of all, because you trust it. Okay? Remember, as I said in the last episode, data is important. Data will live longer than code, so trust is important. All right. 3 different databases: SQLite, MySQL, Postgres. I am going to give you the quick greatest hits on these things. SQLite, very, very, very fast. Okay? SQLite is exactly what it says. It is a lightweight SQL database, and it is designed mostly for use in a development context. Okay? In other words, when your development system isn't powerful enough to run a big database like MySQL or Postgres, you run SQLite. Okay? Very often it is used in a test context, i.e. when you're testing your software, your test engine runs SQLite, because SQLite is screaming fast. Now, that said, I am not a fan of running SQLite, and the reason is that when you develop software, the more the software you develop locally in development is close to the software you develop in production, the better off that you are. Okay? And the reason is the fewer differences between development and production, the fewer the bugs. And even though SQLite is a SQL database, and MySQL is a SQL database, and Postgres is a SQL database, they all will speak slightly different variants on SQL. Yep. Welcome to standards, people. The only good thing about them is that we have so many to choose from. Okay. So, SQLite, screaming fast, very powerful, very good piece of work. I respect the people that write it. I just think the context of having your development system be the same as your production system outweighs the speed. Next database, MySQL. I love MySQL. I am a fan. I know the people who write MySQL. I know Monty, who created MySQL and now creates the database MariaDB. And MariaDB, it's MySQL, only better and not encumbered by Oracle. Historical side note, MySQL is written by a guy named Monty. Monty has kids because he's also a dad, and one of Monty's kids is named and that's why it's named MySQL. Another one of Monty's kids is named Maria, and that's why his next database was called MariaDB. Okay? All right. So MySQL has a number of attributes, and in particular, MySQL is generally fast. Okay? It tends to be faster than Postgres, although context matters, benchmarking matters, etc. Okay? MySQL, generally speaking, has less features than Postgres and is less standards compliant. Okay? And this reflects the different development goals of MySQL versus Postgres. When Michael Stonebreaker wrote Postgres, he said, gosh dang it, I'm going to be standards compliant. And he made it standards compliant. Like, you can't do non-standard stuff in Postgres very easily. Okay? Whereas MySQL said, you know what? We're going to trust the developer and we're going to make it fast. If you try and put a paragraph of text, i.e. something greater than 256 characters, in a string field that's limited to 256 characters, MySQL is going to let you do that. Postgres is going to throw an error. These are both valid choices, I would argue. They are simply things that the developer needs to understand. Okay? All right. So I referenced earlier trust. Okay? That you trust a software tool, and that's one of the reasons you use this. So most of my web stuff has been developed using MySQL, and the reason for that is circa 2003 to 2006, I ran a blog search engine, and one of the characteristics of the blogging world is the data changes very, very fast. Okay? So people might write a blog post, and then write another one the same day, and then write another one the same day. All right. Now, so I used MySQL to store that data because it was fast. Now, this was, by computer standards, this was 15 years ago, and times were different. So we used what was called a storage array network, a SAN, just to run the storage for all of our databases. And there was one time that I was in the data center, and, well, someone, I'm not going to name names, parentheses, me, parentheses, tripped over a cable and yanked that SAN killed the power on that SAN. And this stuff should never, ever happen. So we took a multi-million-dollar piece of storage hardware and we killed the power to it at runtime. Okay? And I watched that server come back up, and I watched MySQL come up, and I knew I had been watching the logs as this ran. MySQL did not lose a beat. We did not lose one single blog post. That, to me, is phenomenal. Okay? And from a computer science perspective, that means they use a storage architecture that's called journaling and checkpointing. And basically what it means is that they know how to write software that can survive disaster conditions like, I'm going to be an idiot and trip over a power cable. Because yes, in the real world, crap like that happens, right? And ever since I saw that, I trust MySQL. All right? Now I trust it, but it's still got issues, and specifically, if I do the wrong things with it, it is going to not support me. I try and put too much data in a column, it's going to let me. I try and put the wrong type of data in a column, it's going to let me. And that brings us to Postgres. Postgres as a database was created by a guy named Michael Stonebreaker, and it was the successor to his previous database, which was called Ingress. So in and then post. Post means after. Okay. Now, Postgres is, and actually, I should clarify something. Stonebreaker created Ingress. Postgres, which was not open source. Postgres is open source, and I can't remember if Stonebreaker created it or not, or if it was simply built on top of his conceptual work. It has been a while since I've hit that Wikipedia article, but it is fascinating. Anyway, Postgres, like MySQL, is a relational database. It is more standards compliant than MySQL, and it has features in MySQL that either don't exist or have only existed for a relatively short time. And when you have something like a database, you want to stick, in my opinion, to the baseline features, because the stuff that's newest will be the stuff that is buggiest. Okay? It's not that it doesn't work. It's that it might not work as well as you want it to. Okay. 3 open source databases. When to use them? You use SQLite when you want something light and fast. Oftentimes that means you're using it in an embedded context. Like, let's say you're building an internet appliance like a router and you need to store traffic records. SQLite is used a lot there. Okay? One of the characteristics of SQLite is it uses what are called exclusive locks, which means when one process is writing to the data, no other process can write to it. That's generally bad. MySQL, very fast, very powerful, not fully standards compliant at times, although it's a lot better in recent years than it used to be. And if you're using MySQL and you're concerned about the fact that MySQL is owned by Oracle, what you use is what's called MariaDB, which is a MySQL clone based on the same source code, written by some of the same people. Well, there's a reason here, and it's called Oracle, and that's a different topic. Postgres, most advanced open source database, generally speaking. Most standards compliant open source database. It is slower, it is bigger, it is harder to run, okay? And it doesn't do certain things like replication as well. And that's not to say that MySQL does replication well, as to say it does it better, okay? Replication in an open source database context is a crap fest, and it's painful. And it makes certain things work well. Oh, and by the way, replication is what you have when you have a master database and a replica database, usually referred to as a slave, and any changes that happen here are mirrored to here. And the reason you do this is because this can always die. Yes, that's Dad hand talking. Okay. Now, let's talk about the world of non-open source databases, of which there are basically 3 different types. There's basically, or 3 different examples. There's Microsoft SQL Server, there's Oracle, and then there's the different cloud databases that you get from Amazon or one of the other cloud providers. Microsoft SQL Server is an outstanding database. It was originally built on top of Ingress, i.e. Microsoft bought a bunch of code from Ingress. They built on top of it, so it has a lot of characteristics similar to Postgres. It is, however, commercial. It's expensive. It has excellent tooling. So if you like graphical user interfaces, from my perspective, SQL Server has the best tooling around. Postgres is the big daddy of databases. Postgres does things no other database in the universe can do, but you will pay through the nose for Oracle. And did I say Postgres? I meant to say Oracle. But let me restart. Oracle is the big Mac daddy of databases. Oracle can do things no other database can do, but you will pay a price for it, and that price will be expensive, okay? And so you use Oracle these days only when you absolutely have to. And it is very rare in 2020 that you will start a new project with Oracle, okay? And now this brings us to the world of the cloud database. Dun, 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 dun. All right. And if you've been floating around computing in the last decade, you cannot have avoided the word cloud. This just means someone else operating stuff for you in a data center that is not yours, okay, that you access over the internet via an internet protocol. In the old days, we called cloud hosting, and we didn't make a big deal of it. I don't know, maybe it's me. Anyway, there are a variety of cloud databases that you can get from a vendor like Amazon. And for example, Amazon will sell you access to MySQL. They will sell you access to Postgres. Okay? And they will also sell you their own cloud database, which is called Aurora. Aurora is a SQL database built from scratch that is protocol level compatible with MySQL and with Postgres. So in other words, you can talk to it in the same way that you talk to either MySQL or Postgres, and it can do the same types of things, but it is designed to run in this cloud native context. Okay? It is designed specifically for operating across multiple data centers, for keeping data data in sync with each other, and Aurora looks phenomenal. I have not used it myself. The one time I've tried, I've had issues. But Amazon, which is a vendor that I respect deeply for their cloud stuff, has done what appears to be a really good job with Aurora. And if you're doing stuff that's doing big stuff that's on the that's in the cloud, Aurora is something to consider. All right. So, how do you pick your database? You start by looking at your data and seeing what matters, and seeing what the characteristics of the data are and the characteristics of the context in which you're going to use it. For example, if your context is you're writing software that's never going to leave your machine and you're concerned about speed, SQLite's a good choice. Okay, it's fast. If, however, you're going to be writing software that's going to run in a data center, I would look at either MySQL or Postgres. And in particular, you want to look at whether or not Postgres's characteristics, specifically around standards compliance, and a feature in the SQL world called views, specifically materialized views, are worthwhile. If they are, use Postgres. If not, strongly consider MySQL. Okay? And if you're doing stuff that you know is going to be operating at scale, look at Aurora. Aurora is impressive. And if you use Aurora, then you use Postgres in a development context or MySQL in a development context. And yeah, that breaks my rule, but the scalability advantages of something like Aurora give you a reason to break a rule. Okay. If you notice, I did not recommend using SQL Server or Oracle. Ever. Okay? Generally speaking, in 2020, I view that you use these things to support legacy applications. If you have an application that uses SQL Server and you've got to maintain it, you use SQL Server. Okay? Same goes for Oracle. In 2020, however, I would not recommend starting a new application with Oracle or SQL Server, and the reason is that you're effectively applying a tax onto your whatever you're doing. SQL Server is not so great that it cannot be replaced with an open source database, and that tax that you pay for it is expensive. Okay? And like a lot of people, I don't like paying taxes. I will do it. I will gladly support my government, but if I can avoid paying taxes, I will. And that's just called being rational. It's not called being an idiot or being a jerk. Okay, so I've now talked about different databases. All right, or different relational databases, and therein ends this lecture.